All right, guys, so this is 5.7. This is the last section of chapter 5. And this is just going to provide as a review and kind of a piece of our knowledge together. So everything that we've kind of done, all coming into one. This is hopefully what you're going to be able to do by the end of this video, okay? So, and these are the things you need to know how to do. So you need to know how to determine if a graph is a linear relation. So we've done that on page 19 and 20. We have to be able to determine the key characteristics of a linear relation, so slope. So we did that last video here. You need to know what an x and y intercept and how to find them. So we did that on page 7 in our booklet here. Graph a linear relation given a table of values. We've done that quite a few times. State the domain and range of a function. So that's pages 14 to 16 in our booklet here. And state graph equations using function notation. So let's find x and y intercepts here. So again, we've already went through all of this. We went through how to find an x-intercept. An x-intercept is where your graph goes through the domain axis, so the horizontal axis. One thing I want to mention is we are used to seeing this. So an x-intercept can be determined by finding x when y equals 0. It's a little different now that we know function notation. So we remember y and f of x are interchangeable. So we can think of an x-intercept as by finding the x when f of x is 0. So two different ways to think about it. Okay, and your x-intercept is the thing that crosses the x-axis. Your y-intercept, everything's the same as we've talked about. It's when it goes through the range axis, so your vertical axis here. The main difference that we now know is, we used to talk about it in terms of y-intercept can be determined by finding y when x equals 0. We can talk about it a little bit different way, as saying y-intercepts can be determined by finding f at 0. Because remember, y and f of x are interchangeable. And here we have replaced x with 0. So this statement is the same as this statement, just using function notation. Okay, and this would be your y-intercept here. So we've gone through this table before. So let's practice finding x and y intercepts algebraically. So we've kind of done this here and there, but I really wanted to just show you concretely how to do it algebraically. So here we're given an equation, y equals 3x plus 6, and we have to find our x-intercept. So remember, our x-intercept is when y equals 0. So how do I find that? Well, here I just have to plug in my y value for 0 and solve for x. So here I'm going to put 0 equals 3x plus 6. So recognize I've replaced y with 0. And now I'm solving for x. So here's a little bit of algebra. I'm going to subtract 6 from both sides. I'll get negative 6 equals 3x. And then I will divide 3. So at this point, I'm going to get negative 2 equals x. Okay? And remember, if your algebra isn't strong, you need to come in and ask how to do some algebraic solutions. So I'm subtracting 6 here because this is adding to x, and then I'm dividing 3 because this is multiplying x. Okay, so x equals negative 2. Now recognize that this is a coordinate point, okay? We have just plugged in when y is 0, x is negative 2. And remember what coordinate points are. A little reminder, coordinate values always is your domain value and its corresponding range value, or your x and your y coordinates. So in this case, my x is negative 2 and my y is 0. Okay, let's find our y-intercept. So our y-intercept is actually usually pretty much easier to find because it's just when x equals 0. So here I have to take my x value and replace it with 0 and solve for y. So here I have y equals 3x plus 6. So now I'm going to replace x with 0. So this is going to become y times 3 times 0 plus 6. 3 times 0 is 0 plus 6. 0 plus 6 equals 6. So when x equals 0, y equals 6. So here I will get 0 and 6. Okay, and see how these match up with what we were talking about here. My x-intercept is when my y-coordinate is 0, -2 and 0. My y-intercept is when my x is 0, 0 and 6. Okay, let's go to the next one here. So now we're dealing with something in function notation. So I'm going to now apply our second kind of explanation of what an x-intercept is. So I'm going to use function notation to describe this. So here, find the x-intercept for g at w, or g as a function of w, equals -4w plus 5. So remember, this is not g times w. This is g as a function of w, okay? And at this point, your x-intercept, again, is when y equals 0. Well, in this case, y is represented as g of w. So it's also known as when g of w equals 0. So I'm going to replace g at w with 0. So this will become 0 equals -4w plus 5. And now I'm going to do my algebra. So remember, when you're solving algebraically, you do BEDMAS backwards. So what's the thing subtracting w? Nothing is subtracting w. -4 is multiplying w, and 5 is adding. Now you go to add. 5 is adding to w, so now I need to subtract. And I will end up getting -5, because 0 minus 5 is -5. This equals -4w. Now I need to get rid of the thing multiplying by w, which is -4. So I'm going to divide -4, and I'm going to be left with w equals, recognize a negative and a negative give you a positive, and then 5/4. You could represent this either as a fraction, or you could put it into your calculator, and you will end up getting 1.25. So here, the coordinate of my x-intercept would be, remember, this is my range, this is my domain. So these are my domain values, these are my range values. Okay, so what was my range here? Well, again, an x-intercept is when your range is 0. What was the value of w? It's 1.25. So there's my coordinate point for my x-intercept. 1.25 and 0. Let's figure out my y-intercept. So again, my y-intercept is when x equals 0. So we can also represent this, or sorry, not really my x. Remember, my x is actually w in this case. So this would make more sense of saying when w is 0. Because remember, my x coordinate, or my x value, is now w in this type of equation. So we are really asking, what is g at 0 equal? Because I simply replaced w with 0. So here, I'm going to get g at 0 equals -4, and now I'm going to replace 0 with w. Or, sorry, I'm going to replace w with 0, okay? So this will be 4 times 0 plus 5. And now I'm solving. -4 times 0 is 0. Okay, and then g at 0 equals 5. Recognize and remember that this equation can be represented simply by g equals -4w plus 5. So you could also say simply that g equals 5 when w equals 0, okay? And remember, our w is our domain, and our g values are our range. So here, my y-intercept is when my domain is 0, which is what we plugged in, my range value is 5. Okay, so it definitely gets a little bit maybe more confusing once you don't have x and y being represented. But you have to remember, sometimes it's not always x and y. Sometimes it's different variables. Okay, let's do one more. we have the equation t of x equals 5x. So it wants us to find the x-intercept. Remember, we could technically represent this as t equals 5x. Okay? Because remember, this is just a function notation. T as a function of x equals 5x. If I want to just write it as a normal equation, it's just t equals 5x. So an x-intercept is when your range value equals 0. So in this case, when t equals 0. And then you're going to solve for x. So here I'm going to get 0 equals 5x. So I'm replacing t with 0, and I'm going to solve. So I'm going to divide 5. 0 divided by 5 gives me 0, so 0 equals x. For some reason, I'll fix this. So coordinate point of x-intercept. Okay, and then I'll do this. Just so mine looks exactly like yours. Sometimes my formatting gets a little messed up when I convert this. Anyways, so now remember, a coordinate point is always your domain and then your corresponding range value. Well, what's my domain value? Well, that's my x-intercept, which is 0. So this is 0. And what was my y value or my range value? Well, that was t is 0. So it's 0 and 0. So my coordinate point would just be, or my x-intercept is actually the origin point here. Let's do one more. So y-intercept. So y-intercept in this case is when your domain value, which in this case is x, equals 0. So I'm going to replace 0, or I'm going to replace x with 0. And then I'm going to solve here. So anywhere where I see x in my equation, I'm putting 0 in. Recognize it might be easier to just represent it like this. T equals 5 times 0. Remember, these two things aren't multiplying. This is saying t at 0. That's a sentence right here. T at 0, right? And this is what t at 0 is. I'm just going to get rid of my function notation and simply represent it as t. And now 5 times 0, well, that gives me 0. So in this case, my domain value was x equaling 0, and my corresponding range value was 0. So here, and this sometimes happens, if you ever go through the origin point of a graph, and an origin point is this point right here, that is known as your origin point. And there, if your graph goes through that, you have an x-intercept and a y-intercept at the same place. And that's the only place that's going to happen. Okay? So make sure you go practice how to find x and y-intercepts, as it is very important to understand. Normally, you are going to just be dealing with variables of y and x, so it makes it a little easier. But it is important to understand and see how you would solve it where the variables aren't just simply x and y. Okay, we're going to do one more last example. And this example is a word problem. Okay, so here, Mr. Skaber, so myself, I'm going to go to the bank to start an investment. The bank is having a deal where an investment over $1,000 gives you $200 to invest. Mr. Skaber decides to invest $1,000 with his bank. Every year, the investment is supposed to grow by 12% of the original amount invested. And this is known as a principal investment, okay? So pretty much, no matter how long I keep it in, this thing's just going to keep growing based off of the $1,000. So let's create a table of values showing how much money Mr. Skaber has after 6 years. So I'm going to make a table of values here. And remember, in my table of values, the things on the left-hand side, well, this is going to be my domain. Meaning this is my independent values, or variables. Okay, over here will be my dependent variables, making this column my range. Okay, and I'm actually just going to write that down here. Now, remember, an independent variable is something you either decide or you have no control over. Think about what I do not have control over. I don't have control over time. Remember, anytime you're dealing with time, it's pretty much always going to just go be placed in your left column as your domain. So here, this will be time, and I'm going to measure it in years because my thing grows, my investment grows every year, okay? Now, because it says every year, there you go. Every year the investment is supposed to grow 12%. So that's why I put T as years. Now, what's responding to the amount of time? Well, that's the amount of much I've made. So this is how much money Mr. Skaber has. So I'm going to put money here. And that's measured in dollars, of course. And from here now, I'm going to start creating a table. So I'm going to keep this in for 6 years. So I'm going to go up to 6 here. And now I need to figure out how the heck do I solve how much money I've made in 1 year. Well, remember, and let's write some stuff out. My investment grows 12% of the original amount. So I gain 12% of 1,000 every year. Because that's what I originally invested in. And it's stated here that my investment's going to grow by 12% of the original amount invested. My original amount was $1,000. Something to note here is I got 200 extra bucks just into my account as soon as I invested 1,000. So I have an additional 200 bucks, which is pretty sweet. Now from here, I can kind of start solving. So what's going to happen is in the first year, what happens? Well, in the first year, first of all, let's figure out what 12% of 1,000 is. 12% of 1,000, you need to figure out and put this into a decimal. So 12% divided by 100, that gives me 0.12. So to figure out 12% of 1,000, that's actually 0.12 times 1,000. Okay, and let's figure out what that is. So 1,000 times 0.12. That gives me $120 every year. So here I get $120 every year I have my money in this investment. Okay, so in my first year, I'm going to get my $1,000 plus my additional 120. And remember, in that first year, I got an additional 200 bucks. So this will be add $200. Okay. And what is that going to equal? Well, 1,000 plus 120 plus 200. That gives me 320. So $1,320. So this will be 1,320 bucks. Now let's talk about the second year. Well, the second year, recognize I don't get that additional 200 bucks, but I am going to get $120 because every year it grows 12% of 1,000. So here, I'm going to get $1,320 plus my 120 bucks. And that's going to lead me to $1,440. Let's talk about the third year. Well, again, the third year, I don't get that additional $200 extra amount. I just get my additional 120 bucks after the third year. So here, I'm going to have 1,440, right? 1,440, add my 120. And that's going to bring me to $1,560. Now let's see here if this is a linear relation. So here, to get from 1,320 to 1,440, well, I'm going to take this number and subtract it from this number. So 1,440 subtract 1,020. And that gives me, and you have to add 120 to 1,320 to get to 1,440. Let's see if that works to get from 1,440 to 1,560. So 1,440 plus 120, and it does work. Okay, so we can see 1,560 does equal 1,440 plus 120. So it looks like this thing is going to increase by a linear relation. So there's a pattern going on here. Let's kind of clean up this graph here just so we can see it a little better. Okay, so this is going to continue on. So plus 120. So 1,560 plus 120, well, that gives me 1,680. Okay, and then since this is a linear relation, to get to the next number, we're going to add 120 again. So 1,680 plus 120, that gives me 1,800. And then finally, to get to our final range value, we will go 1,800 plus 120. That gives me $1,920. So now we have a table of values. We can see this thing is linear because it would just follow this trend. We would just keep adding 120 every year. And it looks like he ends off with $1,920. So after 6 years, we almost doubled the amount that we started with, which is an okay investment. So let's graph the following relation. So remember, what does a graph need? Okay, so this is good review. A graph needs a title, axis, titles. There needs to be units, and there also needs to be proper interval increases, increments. So essentially you can't go up by 10, then 20, then 40 randomly. They have to go up at the same time. So what I'm going to do here is I'm going to start off my graph. And hopefully you have a ruler, because unless you have an iPad, then it does it for you, which is pretty cool. And from here, recognize we're starting at a massive number. Now, remember, my independent variable and my domain is always on my horizontal axis. So this is my domain axis, and my domains is my time. So the first thing I'm going to do is I'm going to title my domain axis as time and mention that it's measured in years. Okay, I'm going to figure out what I should go up by and recognize I only go up to 6 from 1. So I'm going to space this out fairly nicely. And this will be 1, 2, 3, 4, 5, 6. I didn't do it perfectly, but recognize I tried to space out these numbers by the same amount of distance. I'm going to move this over a little bit. There you go. Okay. And then for my vertical axis, let's talk about that. Well, recognize we're starting all the way off at 1,320. Okay. So I probably would suggest us maybe starting at 1,000. And what does that mean for our graph? That means I have to erase this little part. So this is something you would have learned maybe in grade 8. And we kind of went over this in one of our other previous videos. But since we're not starting at 0, we're going to do a scrunchy line. Okay, and this indicates not starting at 0. Okay, so we kind of have, you can imagine us squishing our line down and it's all crumpled up there. So we are going to actually start at 1,000 here. And recognize we need to roughly get up to 2,000 up here. So what I'm going to do is I'm going to go up by 100s. Okay, so here this will be 1,100, 1,200, 1,300, and see how I'm trying to evenly space these as best as I can. 1,400, 1,500, 1,600, 1,700, 1,800, 1,900, and then I'm going to extend this a little bit. Ooh. And then 2,000. Okay, now what is this table here? Well, this table is my domain values. Or sorry, my range values. Remember, this is always range. Vertical axis is always range. And what is this? Well, this represents the money, or like, let's say, money earned. Well, it's not actually earned, it's money. It's just money, and this will be in dollars. Now, to be more specific, I should probably mention that this is like how much Mr. Skaber has. Okay, so how much do I actually have? So it might be better to put money in account. That's what I'm going to represent this as. So money in account. And why did I change it? Because money's very arbitrary. Money could be anything. What does that mean? Does it mean money lost, money gained, money earned? Well, it's just money in my account. Now, the one thing I am missing is a title. So I'm going to title this, just for the sake of room. I'm going to put it over here. It should always be on top, but I just don't have too much room. As long as you indicate where your title is. And the title of this is, I'm going to say, money in Mr. Skaber's investment account. And I'm going to underline that. Okay, so that's the title of my graph. And now from here, it's simply plotting my points. Now let's talk about this quickly. When my domain, when time is 0, how much was in my account? Well, that was $1,000, right? I started off with $1,000 and I didn't make anything then. That's just what I started with. Okay. Now, what is my next graph? Well, my time in years is 1, and this will be going to 1,320. So here, I'm going to start off way up here, and that's going to be roughly 1,320. So that's going to be pretty close to 1,300. So I'm going to plot my first point here. Okay, now in the second year, how much did I make? I made 1,440. So in my second year, I made 1,440. So that would be roughly right there. Let's kind of draw a line here to try and be more accurate. Okay, and then erase our dotted lines. Let's go to the next one. Time in years at 3. So 3 is 1,560. So definitely going to need to use my lines to my advantage here. So when I'm at 3 years, I have $1,560. So that's going to be roughly right here. Okay, and then I can erase these. Okay, now onto our next one. So 4 years, I made 1,680. So at 4 years, I've made 1,680. So that's going to be pretty close to 1,070 or 1,700. Okay, and then again, erase your lines. Now we're at 5 years. 5 years I made 1,800, so that's going to be nice because it's right there. So that's going to be right here. And hopefully you can see that this thing is in fact a linear trend because we are going in a straight line. Let's finish this off at 1,920. So that's going to be, that's more roughly right here. Now, should I connect these points? I probably should. I'm just going to make this a little bit more accurate. There you go. And recognize this is a linear trend. If I connect these points, it forms a perfectly straight line. Now, you might be saying, hey, but what about this point? That's because remember, from here to here, we got an additional $200. So the whole entire graph is not a linear relation, but after that first year, this is a linear relation. Now recognize there's some errors that I've made, and I wanted to show you these errors. Look what happened here. I kind of crunched up my scale a little bit. That made my points a little too close together. And even here, my first year and my second year are way different. So what you need to do is you have to make sure that these are the exact same distance away in order for your graph to be perfect. And I will be looking for that in certain types of questions, okay? But that's something to know. I should have used a ruler where I can make sure that the distances between these points are the exact same so you don't get crumpled up data values. But that being said, you still are able to see a linear relation, okay? Now, determine the domain and range if the Mr. Skaber decided to take out all of his earnings at the end of 6 years. So here, this is where it gets a little interesting. Technically, this would go on forever, but we stop at 6 years. So what does that mean for in our context? So sometimes, this is something kind of maybe to note, context can determine domain and range. And what I mean by that is technically this could go on forever and ever and ever, but we're not going to keep my money in to infinity. I want to use it, and apparently I want to use it after 6 years. So my domain is actually going to end at 6 years. We started at 0 and we ended at 6. So my domain, and remember, I'm going to use a squiggly because this is the set of domain. Now, what is domain measured in? Well, domain is t for time. So domain is t, and t is such that it is greater than or equal to 0, greater than or equal to 0, okay? Or 0 is less than t, and t is going to be less than or equal to 6. And can I be in between here? I absolutely can, okay? I can exist in between 1 and 2 here, okay? 1 and 2 years. If I decided to, for some reason, take my money out at 1.5 years, I would get roughly $1,400, okay? So since both my range and my domain are continuous, my t value can be any numbers when they are a number. So it can be a fraction, you can be half a year or quarter of a year, so on and so forth. If I were to state this using interval notation, my smallest number is listed first, and I'm going to use square brackets because I can be at 0 years. Comma, and my biggest number is 6, and I'm going to use a square bracket because I can equal 6 years. What about my range? Well, my range, what is my range in? It's measured in money. Okay, I'm not going to put the units. What I'm going to represent this as let's call it, and let's maybe put it up here. Let's put it in capital M. Okay, so my range is measured in M, and I'll put this as my M axis. Okay, so I've plotted my M axis up here. Okay, so what can M be? Well, M, I'm not going to have lower than $1,000 because I started with $1,000. So the smallest number is $1,000. So since that is smaller than or equal to m, and what do I take it out at the max amount? Well, I take it out at 1,920. So m is going to be between $1,000 and 1,920. Now, can I have money in between here? I absolutely can. If I decide to take it out at 1.5 years, so 1.5 years, I get roughly $1,400. Okay, so my money can be any real number. How would I state that using my interval notation? Well, interval notation, my smallest number is 1,000, so that's going to be listed first. And am I allowed to equal 1,000? Yes, because that's what I start with. So I'm going to use a square bracket. And then my largest value is going to be mentioned, 1,920. And that's going to also be a square bracket. And there's my domain and range. And again, it changed based on our context. We would never make sense to make negative time, so of course time has to be greater than 0. Okay, a few more questions here. Determine the slope. What does it represent? We're not going to determine slope here because that doesn't quite make any sense. What I'm going to actually do is I'm going to use my table to determine the slope of this section of the linear relation. Okay, so my slope here, I'm going to use this section. So remember, slope equals change in range dividing change in domain. So again, what was the change in range? Well, the change in range kept going up by $120. Okay, so this will be $120. And what was the change in my range? Well, the change in my range was 1, right? We can see here, +1, +1, +1, +1. So 1 + 1 is 2, 2 + 1 is 3, 3 + 1 is 4, so on and so forth. So the change in my domain is 1, and what is it represented in? Years. And remember, the units are useful because we can now determine what this represents. So it looks like I increase my amount that I have or own by $120 every year. So what does it represent? It represents that an increase of $120 every year occurs after the first year. And why do I state this last sentence, after the first year? Because remember, in that initial 0 year to 1 year, we get an additional $100 or $200. So it's not really a part of your linear relation. But after the 1 year, then it's a constant steady increase of $120. Okay, let's do the last two questions here. So what does the y-intercept mean? So remember, what is a y-intercept? The y-intercept is when your graph crosses the range axis. So where's our range axis up here? Our range axis is right here. My graph crosses it at 1,000. So what is the coordinate point here? It's 0 and 1,000. So the coordinate point is 0 and 1,000. And this is the initial amount that I started with. So this is the initial amount I started with. And what was the initial amount I started with? So $1,000. And that's stated in my original question. So let's move on to F here. Now F, I'm going to make a quick edit. I want to say state the relation using function notation. Okay, so the relation here is the relation between money and time. Now remember, you always state your range in terms of your domain. So here, the relation is money has a relation to time. Okay. Using function notation, I'm going to say m is a function of t, which is true. Money is a function of time. Okay. In the next chapter, in chapter 6, we're going to actually be able to learn how to find these equations, which is pretty cool. But right now, we just have to know how to represent graphs, how to look at graphs, find slope, determine what slope is, so on and so forth. So that is the 5-point, kind of the review of chapter 5. And looking at how to find x and y intercepts a little more closely and doing kind of a more complex looking problem here. So if you have any questions, please come in and give a few practice problems a shot on your own. Have a good day.